We've got a 2001 Chevy Tahoe. The customer concern is that there is no air conditioning or it doesn't feel cold. First thing we're going to do is we're going to check for codes. Being a 2001, we got to go old school with this, and we're using the Tech 2. Okay, we're going to go to heating and air conditioning. Look for trouble codes. We'll first look to see if there's any current codes, and there are not. Let's see if there's anything in history. We have a B0268 airflow control 7 circuit. So obviously we want to look at the service information and see what that code is saying. Let's take a quick look at our data. And the first thing that really stands out to me is this outside air temp, negative 19 degrees Celsius. Let's change our units. That's negative 2 degrees. It is June in Colorado, and it is not negative 2 degrees right now. It is actually, we're on like a 95 degree day, so this is definitely way off. This vehicle uses 2 outside temp sensors. One is located here, and this provides the value for the display in the rearview mirror. It shows 94 degrees, and that's about the ambient temperature, so I know this sensor is good. The other sensor is located behind the turn signal lens on the passenger side. This sensor reports the value we saw on the scan tool that was showing negative 2 degrees, and this is the sensor I want to test. Let's take a quick look at how the system works. We've got a control module, in this case the PCM, a signal circuit that goes between the PCM and the temperature sensor itself, and then a ground. Typically, this ground comes directly from the PCM. In terms of what can be wrong, there can be a problem with any of these, and there could also be multiple problems. I'm going to show you how to test everything in this system, but I'm going to start with the most likely problem, which is the sensor. So I'm going to take this guy out, and this is our temperature sensor. We've got 2 wires that go to it. This is just your typical thermistor. We're going to test this just like you would any other temperature sensor. All right, to test this temperature sensor, I'm going to use the DYVO forward probes and put those on each pin. I'm going to take my positive test lead. I'm going to connect the alligator clamp to it, and I'm going to put this on a known good ground. So anywhere on the engine, on the battery negative, anywhere that's a known good ground. If you're not sure if it's a known good ground, for example, I just put it on the alternator and it may not be a great connection, I can just verify that that ground is good. I have it in load mode, I get a green LED, 0 volts, so I know that's a good ground. I'm going to place that ground on one of these forward probes. It does not matter which one, you can use either forward probe for this. I'm going to take my other test lead, still in load mode, I'm going to connect it to the other forward probe and look to see that value come down. Look at that voltage value, how that's dropping down like that really, really quick. This tells me this thermistor, this temperature sensor is defective. Right away, I know this is defective. Look at how it just keeps dropping and dropping like that. What we're doing is we're applying a voltage and passing a current through here, and this temperature sensor is defective because that internal resistance is actually shorted. Right? It's maybe not a full dead short, but it's definitely a much lower resistance than what it should have because of how quickly that value drops. And I'll bet you can actually even feel a little bit of heat on this as well because we're basically, it's shorted through there rather than having resistance that would keep that voltage high. So I know for 100% certainty, this is a defective temperature sensor. I'm gonna get a new one coming and then we'll test that and see what a good one should look like. Got the new temperature sensor, it's an AC Delco part. Let's connect this to our new temperature sensor and see how it's different. Now look at how the value on that temperature sensor, it is dropping very, very slightly, nowhere near what the other one was dropping. It's clear that this temperature sensor is defective. You can see what a good one looks like. That value will slowly drop because as we pass current through there, we're changing the resistance, so it actually kind of thinks in a way the temperature is changing. This is how this sensor works. The temperature changes the internal resistance. That resistance changes the voltage drop, and that's why we see that voltage drop decreasing. But again, much different than what we saw from this temperature sensor. Very clear that that one is defective. All right, so we know how to test the sensor. Now let's take a look at how to test the rest of the system. I've still got the sensor unplugged, and I'm going to use the DYVO forward probes into the connector. I need to know which pin is the signal circuit and which is the ground. I could look at a wire diagram to see this, but it's quicker for me to use DYVO to figure it out. To do that, I'm going to take DYVO out of load mode, and then I'm also going to put it into the voltage available rather than the voltage loss mode. With the sensor unplugged, the signal circuit will have 5 volts and the ground will be close to 0 volts. You can use either test lead to identify the circuits. I'm going to use the red one. This circuit has 0.6 volts on it, so it's most likely the ground. Let's check the other circuit. 5.18 volts. This is the signal circuit. Both these numbers look good, but I want to test them a little further. Let's go back to the ground. I'm going to use the black test lead and connect it to my ground circuit. Remember that we're not in load mode, so we're not actually loading that ground circuit down. We do want to apply a little bit of a load to it, so I'm going to push and hold the mode button down. We're going to load that circuit down, and now we can see that it changed to 0.13 volts. We get a yellow LED, which simply indicates that we have some voltage loss on that circuit, but we can see by this value, 0.13 volts, perfectly acceptable voltage loss on that ground side, so I'm not concerned about that. So I know the ground to this is good. Next, I'm going to go out of load mode again, and all I want to do is I'm going to test the signal circuit. Now this is a 5 volt circuit, sends 5 volts from the control module to the sensor, and then the sensor pulls this circuit down depending upon the temperature and the resistance of the sensor. The fact that I see 5 volts here tells me that the control module is sending out that 5 volts. We can verify that that's good. Now, whether the integrity of that 5 volt circuit is good or not, that's still in question. Go back into our data display and let's look at our PIDs here of our outside air temperature sensor. Let's change the units here, and we're still at that -2 degrees Fahrenheit. Now, what I like to do for temperature sensors is to first unplug them. The voltage value should be 5 volts, and the scan tool should show the coldest temperature. That's typically around -40 degrees Fahrenheit. Then use the positive channel on DYVO to pull the circuit down. This is going to cause the voltage value to drop close to 0 volts and the temperature to go to the hottest extreme, which can be 250 degrees or more. This verifies the signal circuit is good and the control module is good. Load mode is off. We see 5.19 volts, and that's exactly what I want to see, so I know that's good. But the scan tool is reporting -2 degrees Fahrenheit and not that -40 that I want to see. This could be a problem. I'm going to turn load on. Now the voltage value drops close to 0 volts, so that's good. But the scan tool is still reporting -2. This means that the wire on the signal circuit is good, but there could be a problem inside the control module because it isn't registering the change. However, on this vehicle, the value shown on the scan tool isn't the live reading. It's the last value the control module wants to keep. The manufacturer does this because they know it isn't possible to have a normal environmental condition where the temperature changes from -40 to 250 degrees within a second. So if the temperature sensor reports a big change that quickly, the control module holds on to the last known value and reports that on the scan tool. That's why it still says -2. Now, not all vehicles use this, and many of them show the change instantly. On this vehicle, if I wanted to make sure the control module was receiving the correct voltage, I could always connect DYVO on both ends of the wire, just like your typical resistance test, and verify the voltage values are the same. I'm not going to show that in this video, but know that that's always an option. I'm going to install the new temperature sensor. With the new sensor in, I'm going to go and clear the codes Let's go back in and see if the codes are there. All right, so no codes at this point. Let's check our history. And no codes there. Now again, because it takes so long to update, I'm going to go into the PIDs and I'm going to look for the outside air temperature sensor and notice that it hasn't changed at all, -2 degrees, because again, it takes so long for this to update. So I'm going to try something. I'm going to try to force this to update. I'm going to go into special functions. I don't know if this is going to work or not. We're going to set up a new HVAC. Okay, let's make sure the ignition is on. It is. Okay, this does have the auxiliary, so we're going to save that. It's already got the asterisks with it, so we're going to save those options. And that should be it. I'm going to key this off and see if it... See if we've got any changes. And it does, updates it immediately to 89 degrees. So that fixed the problem. We just verified with that, with 100% certainty, that temperature sensor was defective. It was reading, way off. And by updating that, by going into the special functions, we're able to see that PID change a lot more drastically. So what that means is we could have at the beginning, when we were using DYVO to load the circuit down and it was sitting at 5 volts, we entered the load mode and we pulled that circuit down. We could have actually gone into the Tech 2, gone into the special functions and updated the HVAC module to see that change immediately. And by seeing that change, you would have then known that the wires in the circuitry as well as the control module were all functioning as they should. That's probably a good way to do it. Again, this was kind of a quick and dirty way of just getting in, testing the temperature sensor, and testing that 5 volt in the ground circuit. Thanks so much for watching, and we'll see you in the next one.